Look at the problem on your screen and take a moment to try solving it. In the previous video, we derived the first and second equations of motion and also solved a numerical problem using them. But if you try solving this question using only those two equations, you'll soon realize that something is missing. So how do we solve it? The answer lies in the third equation of motion. In today's video, we will derive the third equation of motion from first principles, understand its physical meaning, and then come back to this very problem. By the end of the video, you'll be able to solve it in just a few steps. Welcome back to our motion in a straight line series. Let's get started. The first equation of motion is v equals u plus at. Now, let's rearrange this equation to get an expression for time. We get t equals v minus u divided by a. Next, let's look at the second equation of motion. S equals ut plus half at squared. Now, we will substitute the value of t from the first equation into the second equation. So, wherever we see t, we replace it with v minus u divided by a. After substitution, we simplify the expression step by step. On solving and rearranging the terms, we finally obtain v squared equals u squared plus 2as. And this is the third equation of motion. Notice that this equation does not contain time. It directly relates velocity, acceleration, and displacement, making it very useful for solving many problems in kinematics. Before we solve the numerical, let's quickly summarize when to use each equation of motion. Whenever you solve a problem, the first step is to identify the quantities that are given and the quantity that you need to find. If the given parameters are acceleration, initial velocity, final velocity, and time, then the first equation of motion is the most suitable choice. If the given parameters are acceleration, displacement, initial velocity, and time, then you should use the second equation of motion. Finally, if the given parameters are acceleration, initial velocity, final velocity, and displacement, then the third equation of motion is the correct choice. Notice one important difference. The first and second equations involve time, whereas the third equation does not. So, whenever time is missing from the given data, the third equation of motion is often the best place to start. Now, let us solve the numerical problem that was shown at the beginning of the video. The problem states that a ball is thrown vertically upwards with a velocity of 20 meters per second from a height of 25 meters above the ground. We need to find the maximum height reached by the ball from the ground and the total time of flight until it hits the ground. As usual, let's first list all the given information. Before we do that, let us note an important sign convention. Any velocity, displacement, or acceleration in the upward direction will be taken as positive, while anything in the downward direction will be taken as negative. The initial velocity of the ball is plus 20 meters per second. The acceleration due to gravity acts downward with a magnitude of 10 meters per second squared. Therefore, we write the acceleration as minus 10 meters per second squared. The ball is thrown from a height of 25 meters above the ground. Now, when the ball reaches its highest point, it comes to rest momentarily before starting its downward journey. Therefore, the final velocity during the upward motion is 0 meters per second. Let us denote this velocity as v1, equal to 0 meters per second. Finally, we are required to find two quantities. The first is h1, which represents the maximum height of the ball above the ground. The second is tf, which represents the total time of flight of the ball from the instant it leaves the thrower's hand until it reaches the ground. Let us start by finding the maximum height reached by the ball during its flight. For the upward journey, we already know the values of the initial velocity, final velocity, and acceleration. We are required to find the displacement, s. Whenever we are given u, v, and a, and need to find s, the third equation of motion is usually the quickest choice. So, let us write the third equation of motion. V squared equals u squared plus 2as. Now, substitute the values from the problem. The final velocity at the highest point is 0 meters per second. The initial velocity is 20 meters per second. The acceleration is minus 10 meters per second squared because gravity acts downward. Substituting these values into the equation and simplifying, we obtain s equals 20 meters. This displacement represents the additional height gained by the ball above the point from which it was thrown. However, the question asks for the maximum height above the ground. The ball was already 25 meters above the ground at the instant of release. Therefore, the maximum height above the ground is equal to the initial height plus the additional height gained. So, h1 equals s plus h. That is, h1 equals 20 plus 25. Therefore, h1 equals 45 meters. Hence, the highest point reached by the ball during its flight is 45 meters above the ground. Now, let us calculate the total time of flight of the ball. To do this, we need to understand that the total time of flight consists of two parts. The first part is the time of ascent, which is the time taken by the ball to move upward until it reaches the highest point. The second part is the time of descent, which is the time taken by the ball to fall from the highest point to the ground. Let us first calculate the time of ascent. We will denote it by TA. For the upward motion, we know that the final velocity at the highest point is 0 meters per second. The initial velocity is 20 meters per second. The acceleration is minus 10 meters per second squared. We are required to find the time of ascent. The equation that relates these quantities is the first equation of motion. V equals u plus at. Let us rearrange this equation to make time the subject. This gives t equals v minus u divided by a. Now, substitute the known values. The final velocity is 0. The initial velocity is 20. The acceleration is minus 10. On solving, we get TA equals 2 seconds. So the ball takes 2 seconds to reach the highest point of its trajectory. However, this is only the first part of the total time of flight. Next, we need to calculate the time taken by the ball to travel from the highest point back to the ground. Now, let us calculate the time of descent. For the downward motion, the ball starts from the highest point and falls all the way to the ground. The total distance of this fall is 45 meters. At the highest point, the ball is momentarily at rest. Therefore, the initial velocity for the downward journey is 0 meters per second. The acceleration is minus 10 meters per second squared due to gravity. We are required to find the time of descent, which we will denote by t subscript d. Since we know the displacement, initial velocity, and acceleration, the most suitable equation to use is the second equation of motion. S equals ut plus half a t squared. Now, let us substitute the values. The displacement is minus 45 meters because the motion is downward. The initial velocity is 0. The acceleration is minus 10 meters per second squared. Substituting these values into the equation and simplifying, we get minus 45 equals minus 5t squared. Solving further, t squared equals 9. Taking the square root, t equals plus or minus 3 seconds. Since time cannot be negative, we take the positive value. Therefore, td equals 3 seconds. Now we have both components of the total time of flight. The time of ascent is 2 seconds. The time of descent is 3 seconds. Therefore, the total time of flight is tf equals ta plus td. That is, tf equals 2 plus 3. Hence, tf equals 5 seconds. Therefore, the ball remains in flight for a total of 5 seconds before reaching the ground. Thanks for watching. If this video helped you understand the third equation of motion, don't forget to like, share, and subscribe. It really helps the channel reach more students. In the next video, we'll solve this JEE question on motion in a straight line and strengthen these concepts even further. See you in the next one.